Hello, this video is for Stat 210, Handout number 9, Part C, and includes pages 17 through 28 of Handout 9. All right, let's go ahead and get started. So we are again going to be using the U.S. counties demographics data, except now I'm going to be concerned about the variable that is associated with health insurance. This data set can be found again in our Google folder for Handout 9. The variable that I am going to be using in Handout, or Part C here, excuse me, is the percent uninsured. So this is just the percent of people that are 65 years and younger that are uninsured in that county. The first thing that I did there in the notes on the handout is created a map. So I'll go ahead and create a map again, and this is just going to be for percent uninsured. So let's go over into Jump and show you how that's done quick. Going to go graph builder. Again, going to be selecting state here. Drag that into the map shape box. So the reason I only got the picture of Minnesota is because I initiated that from my Minnesota data set. So this is the wrong data set. So let me close that one and do that one more time. I want to initiate that from the data set that has all of the different states in it. So graph builder, place state down here in the map. I'll get my picture of the United States. We also could use county if we wanted. So if we wanted to do something by county, it'll try to do that with all of the counties in the United States. We're going to keep it at kind of a higher up level and just do stuff at the state level here. So now I'm going to be pulling percent uninsured here. Again, that standard scale, we can change that easily. I usually pick the green to the red. So red being very high uninsured here. So Texas has a very high uninsured rate. Minnesota, you can see, is quite green. Minnesota, Iowa, Illinois, Wisconsin. All of these up in this part of the United States are quite green here. Also, we have some pretty good chunks of green, low uninsured out here in California, Oregon, and Washington. So before I showed you how to use row selection, select where, I want to actually pull off Texas here. So if I wanted to get just Texas, I would say row selection, select where, and specify Texas. Another way that I can actually pull off Texas is just by double-clicking Texas here. So I'm sitting over the top of the map that I made, and I'm just going to double-click Texas. And what that's going to do is select all of the rows for Texas. Okay, so that's equivalent to doing the where statement. Now this is kind of nice because if I hold the control button down, I can get Minnesota, and I think one of the others that I was going to do is maybe Wisconsin. So now you can see that my selected rows here are Texas, Minnesota, and Wisconsin. And I did that by just holding the control button down. That allows you to do multiple selections. So here I'm just going to do Texas to start with. It has 254 counties in it. Once those have been again selected, so if I fly down to Texas here, you'll see that Texas has been highlighted. I just need to do tables, subset, selected rows, and now I have my table for Texas. And we're going to do some standard graphics here for Texas. So that's what Handout C is going to cover, is just some standard graphs. First one that we're going to look at is the dot plots. I can create that underneath the graph builder. Okay, I showed you that on the previous video. I can do that real quickly here. This is just for Texas. Graph builder. And I'm looking at percent uninsured. Drag that down on the bottom there is where I put that. And then I just want to stack these on a positive grid. Say done. Now one thing that I did on many of the graphs in the notes is change that scale down to 0. So again, I can just double click on that axis there, and I can specify the minimum and the maximum value on my scale. And I think I was using every 2. So that's what the graph looks like that we created in the notes. So again, double clicking here, you have lots of options to put for where the scale starts and stops, etc. That's just a dot plot. Dot plot of the Texas counties. And what I'm looking at is the percent uninsured. One nice thing about a dot plot is I can easily see outliers. They're really easy to see. I can actually see all of the observations. I can see where data tends to be condensed. 18 to 22 here. Looks like I got a lot of data there around 18 to 22. Now one issue with the dot plot is that it's not so good if I got lots and lots and lots of observations. What we usually create in that context, when I have too much data to kind of look at on dots, is a histogram. And a histogram is simply a bar chart for numerical data. What I do with a histogram is I just create bins, like how many data points are between 10 and 12. If I go up here and look at my dot plot, it looks like I had one observation between 10 and 12. How many observations are between 12 and 14? 12 and 14, I must have 9 observations in that bin. So we just create these bins here, and then we just count up the number of observations in each bin. We just create a bar graph of what's left. Now, most of the time, bar graphs have gaps between the bars, but here we close them because we want this to be kind of a continuous scale. This kind of goes continuously from about 11 up through 34. So by closing the gap between the bars, it tends to make it look like it's more continuous. And that's a histogram. These are very, very common in practice. In fact, I argue that they're too common. They're overused in practice. I think dot plots are underused in practice. So here, I'm showing you all of the counties in the entire United States. On the left is a dot plot, and on the right is a histogram. You can see that that's kind of hard to, I got a lot of gaps in here. Kind of hard to tell where it kind of starts to smooth off a little bit. Comes drops, but where does it kind of smooth off? Looks like it's maybe 24 or 20. There's kind of a drop there. Some of that's a little bit easier to see with a histogram. So when I have lots and lots of observations, a histogram tends to be more common measure or more common graphic, than a dot plot. On a histogram, we can add a normal curve if we want. So I think I'll go over and show you some of these things and jump, and then we'll come back to the notes. So this is my Texas data again. I'm going to select Analyze, Distribution. I'm looking at percent uninsured. I'm going to stack that so we can see it a little bit better. I can add kind of a bell curve over the top of my histogram. Let me go ahead and get rid of this box plot. We're going to talk about that in a minute. So I can add a bell curve over the top of my histogram. I do that by continuous fit normal. And this is what that data would look like if a bell curve, if this data followed a bell curve. That's the pattern that we should see. It actually doesn't do too bad. Probably chop off some of this and fill in some of these holes underneath, but it looks fairly bell curved. I can do a smooth curve as well. What a smooth curve does is it doesn't just use a bell curve, but it just allows the histogram itself to determine kind of the trend or the pattern. That's the green line here. And you can see that the smooth curve actually spikes up a little bit more and it decreases more rapidly than the bell curve. I can adjust the amount of smoothing that's done here. So underneath it's called a kernel smoother. I can adjust how much smoothing is done by just sliding that bar back and forth. So kind of what the idea of a smoother is that it basically looks at kind of connecting the tops of each of the bars. So the way that I have that green curve set right there, that's kind of the big idea of a smoother, is to simply connect the tops of the bars here. Now, one thing about a histogram that's actually kind of bad is that the number of bins that I use can change my perception of shape. So here I'm just changing the number of bins. And that might give me a different idea about shape. So we want to be careful when we're doing this. One problem with building histograms is that the number of bins that you use could actually influence what kind of shape you're seeing. And what I did to do that is just selected this here to change the number of bins. You just left click and slide that up and down, and that'll change the number of bins. Let me go back to my arrow here. Some other things that I can do long as I'm here is what's called a normal quantile plot. We'll talk about that in the notes here in a minute. Other things are CDF plot. So from my red drop-down menu, I can obtain a CDF plot. We'll be talking about that in a minute. Okay, so again, the bell curve is just put over the top using continuous fit normal. And again, that looks like a pretty good fit here. You always want to kind of stop and look at how good that fit is, and it does pretty good. Again, I'd like to chop some of this off and fill in some of these holes, but for the most part, it's pretty close. Here's the histogram with the smooth curve. Again, the smooth curve is pretty close to that red normal curve. Page 22 is a normal quantile plot. So this is on the x-axis here. I just have the percent uninsured. So those are the data values. And then on the y-axis, what we actually have here would be the quantiles or percentiles off of a normal curve here. And if this follows a normal curve, then these dots should fall exactly on that red line. And it does a pretty good job. It gets off a little bit here between, what is that, between 24 and maybe 26 right in here. You can see that my points are deviating from that line a little bit, right around 22 to 24, maybe up to 26. And again, in our histogram, that's right in here, 24, 26, right in here. These gaps are not really following. These gaps indicate that I'm not really following that normal curve that closely in that area. And we're picking that up in that normal quantile plot. So again, if I have nice normal bell curve type data, these dots are going to fall nice and straight on that line. If they start to deviate way outside of these bands, which I'm getting a little bit of deviation here, but if they jump way outside of these bands, then the data is not going to be bell curved. That's a normal quantile plot. How about the box plot? So I didn't show you that back here in Jump. Let me go back there and bring that back quick. The outlier box plot. I can get rid of the histogram now. So again, these drop-down menus contain all sorts of things, whatever you would like here. You can turn things on, turn things off. Here's the box plot. So let's talk our way through a box plot. It's a common measure for numerical data. One thing nice about box plots is it gives me some of the measures of position are included. So for example, the minimum and the maximum, the median, Q1 and Q3, they're all included in a box plot. They also give me an idea of spread. I can see the range, which again is not a very good measure of spread, but I can see that on a box plot. I can also see the interquartile range. Another really nice feature about box plots is that they can be used to identify outliers. It is one of the two acceptable ways to talk about or identify outliers. The identification of outliers or outlier detection is going to be on part D of this handout. So that's what part D is. So here the middle line in that box is the median. The left edge is Q1. The right edge is Q3. The width of the box is the interquartile range. We have a lower whisker and an upper whisker. Okay, so these lines that extrude outside of the boxes there are called the upper and lower whiskers. And then any observations that sit below that lower whisker or sit above the upper whisker would be considered outliers, and I've highlighted those here. So it looks like I have about 1, 2, 3, 4, 5 outliers on the high end, and this is for Texas, uninsured, and this is at the county level. So I've got 5 really extreme counties in Texas that have very high uninsured, upwards of 1/3 of the people here. I also have one county in Texas that's really low as well. Okay, those are box plots. Yes, let me show you how to identify those outliers. So I'll do this in Jump. Let's come back to my outlier graph here. What I want to do is go to my data sheet. So what I want to be able to do is identify which outliers these are, which counties these are. To do that, I can select on county. Now I'm looking at only the Texas data. I want to select county and select label. And what that's going to do is put a little name tag next to county. Now when I hover, it's going to tell me what county that is. So when I hover over the top of that, it's going to tell me what county that is. It's actually Gaines County, Texas. How about the next outlier down? That is Collingsworth County, Texas. How about this one way down here that's doing very well? That's Williamson County, Texas. So when I hover now, I get the county information. And the reason that's coming up is because I've selected a name tag here for county. That's called labeling or unlabeling. If you want to turn that off, you can just select unlabel there, and that'll go away. Another thing that I can do is pull those counties out. Again, I can do this by the select rows. So if I go back to my graphic, I highlight all of those 5 on the top side, hold the control button down, and come down here and highlight the one down here on the low end. So again, the control button allows you to highlight in 2 different areas or regions. I go back to my Texas data now, so onto my spreadsheet, and you can see that I have 6 observations selected. That's going to be this outlier down here and these 5 up here. So again, I got rows selected, and we've done this enough. I can pull a subset out of that, selected rows, and here are those counties. So the counties here, I'm only looking at percent insured, so here's the counties. So Williamson County was the real low one there at 11%. That's the one that's down on the bottom. And then these other 5 here are the ones up on that top end. And that's how I created that table that I put in the notes, is just by selecting those and then going table subset. So there's a couple of different ways there that you can use to identify the outliers. All right, how about a CDF plot? I showed you where to obtain that. That was just from the red drop-down menu. So like box plots, a CDF plot, or sometimes it's a cumulative density function. That's the name of this thing. And what a cumulative density function is, it is basically all of the quantiles, all the way from 0 all the way through 100. It's that entire spectrum of data, or quantiles. Now this is especially useful when there's comparisons to be made. So on this plot, what goes on the x-axis is the data values, and what goes on the y-axis is those quantiles, or those cumulative proportions. So just some questions here to drive the discussions. What is the smallest percent uninsured for the Texas counties? What you want to do here is just identify where the 0th or the minimum value is. Well, I guess I can cheat and look over here. It's at 11.4%. But I can see that on the graphic that it's just a little bit under 12. What's the largest? The largest would be the 100th percentile. So I would just go over on this line. The largest here, where does that touch that top line? And it's at about 34, it looks like. So the largest uninsured is going to be, there's one county in Texas that has an uninsured percentage at 34%. Now, you can get these from the quantiles as well, but let's talk about number 3. What proportion of the counties have an uninsured rate above 25? So to determine that, I just need to go from 25 here, go all the way up until I hit this line. And that is about, let me zoom in maybe a little bit and show you that. So we were doing 25 there. Well, that's going to be at about 85%. So 85% are at 25 or less. That's going to leave about 15% up here. So you got to worry about, are we talking about below 25 or above? And that question was asking what proportion have rates above 25. So that's going to be about 15% here. Again, that's kind of hard to see over here using the quantiles, but I can pick that up easily off of my CDF plot. So what proportion of the counties are between 20 and 25? So let me go ahead and zoom in one more time there. So now I'm talking about between 20 and 25. So 20 is going to be right about here. That's about a little bit under 40%. And 25 was right in here somewhere, which was at about 85%. So 85% minus 40 would be 45. So maybe it's a little bit over 40, or a little bit under 40 here, excuse me. So from 85 to 38, that's about 45, 46, 47%, somewhere in there. So to answer that question, a little over 45%. You can go ahead and hit pause here in the video if you want and answer those other questions. Okay, how about the comparative displays? Comparative displays, we can certainly use box plots that are stacked, dot plots that are stacked on top of one another. Again, the real nice advantage of dot plots is that I can see where data tends to be condensed. I can also see outliers real easily on a dot plot. We could use stacked box plots. Stacked box plots here for Minnesota, Wisconsin, and Texas. I have a couple more questions here. So go ahead and answer those. Hit pause and try to answer those. Let me show you quickly how to create these stacked box plots inside of JMP. How I did this was underneath the graph builder again. So let's go and show you that. And this was for, let's see here. I need Texas. Sorry about that. I need Texas, Wisconsin, and Minnesota. So this is going to take a little bit more work. I'm going to actually show you this with a local data filter. I haven't shown you that yet. All right, so let's go to the, I want to go to the original data, sorry, with all 3,220 here. And I want to do side-by-side box plots. So I'm going to select Graph Builder here. I'm going to put % uninsured on the bottom. And then I'm going to put state over here on the side. And then I want to select the box plots here across the top. So across the top here in my graph builder, I'm selecting the box plots. Now I only want, this is doing it for all 50, okay, all 50 states. I want to do this just for a few states. So I'm going to go ahead and say done here. And now I'm going to apply a local data filter. So I go under Graph Builder and say Local Data Filter. I want to filter on state, and I only want to use Minnesota, holding the control button down again, Texas, and Wisconsin. Make those a little skinnier if I want. And what I did on the notes is I put that scale all the way down to 0 there. So that's using a local data filter. So that's another way to accomplish that if I only want to. The nice thing about a local data filter is I could add in another county if I wanted. So if I wanted to look at New Mexico, I can just easily add New Mexico there, holding the control button down. Or what does New York look like? New York is really condensed here. Florida is another one down south, or how about Mississippi or something like that? Mississippi tends to have, Mississippi here is also shifted up. Although there are 3 counties that are doing pretty good in Mississippi, at least relative to the others. Now if I wanted to grab all of these outliers, again, I could just highlight those. And over in my data set, you can see that I have a total of 12 rows selected. So I could do table subset and pull those outliers out and see what counties those are. And that would be doing it across Wisconsin, Texas, Mississippi, and Minnesota. So that's how to create the side-by-side box plots. And here's pulled out the outliers for those 3 states, Texas, Wisconsin, and Minnesota. I pulled those out and just showing you that. How about a comparative CDF display? A comparative CDF display, you're going to have to go underneath Analyze, Fit Y by X. So let me show you how to do that quickly. Let's go back to our original data set with all 3200. I'm going to select Analyze, Fit Y by X here. Making comparisons across the state. What are you comparing? Percent uninsured. This looks a lot like what I saw in the graph builder. And now I want to do CDF plot. Now the CDF plot is going to be very confusing and kind of ugly because I have all the states on here. So what I want to do is just isolate on those 3 states, Minnesota, Wisconsin, and Texas. So here I'm going to apply a local data filter on state again and just select the 3 states. And you'll notice that all of these other ones will disappear for me. So that's Minnesota. Here's Texas. And there is Wisconsin. So that's how to create displays with comparative CDFs. One other thing that I'm going to show you at the very end of the notes is densities. You can compare densities. So these are just the smooth curve densities. And if I have those 3 selected, it'll just compare the smooth curve densities. Okay, these are like the histogram things with the smooth curves over the top of them for Minnesota, Texas, or Minnesota, Wisconsin, and Texas. All right, back in the notes, page 28. We have some questions here about the CDF plots. Texas has shifted considerably to the right. So what does that mean in the context of this investigation? Well, across the bottom here is the percent uninsured rates. And if that's shifted up quite a bit, that means Texas has more or a larger percentage of uninsured. Way more than Minnesota and also Wisconsin. Minnesota and Wisconsin are much steeper here compared to Texas. That means Minnesota and Wisconsin is a lot less spread out. We have a lot of counties. Let's pick Minnesota here, for example. We have a lot of counties that have an uninsured rate between 4 and 8%. And this band right here, between 4 and 8%, we have a lot of counties in that region. From here over to here, Minnesota has all of their data. Sorry, that should be from 4 up to 8%. This bottom one here. Most of the data is stuck between 4 and 8% for Minnesota. Wisconsin's also very tight. Okay, they go from about, 5 up to about 10 here. Wisconsin does have a couple of counties here, or one at least, or a few, I guess, here. Every little step on this picture is another county. So Wisconsin actually has a few up here above 10%. You can see things like Texas best, the best county in Texas, which is at about, 11%, I think. The best county in Texas, okay, is doing worse than all of the counties in Minnesota. So I don't know what Minnesota is doing to keep the percent uninsured in check, but they're doing a very good job. Wisconsin's also doing a pretty good job. There are a few people or a few counties in Wisconsin where that's getting somewhat high, up there above 10%. This skip off to the right here, so that's question 9. The skip, when this jumps up like that, that's that outlier for Wisconsin. So if we go back and look at the box plots, I had one big outlier for Wisconsin, and that's going to show up in this CDF plot with a large skip like that, where it jumps up real quickly. That means you have an outlier on that upper end. So real quickly, when we make comparisons, we almost always do that with some sort of summary statistic. If we go back to part A, I actually said that one big advantage of the summary statistics is that I can easily make comparisons and rank things. If I use that approach here, I can get the median uninsured at Texas, Wisconsin, and Minnesota. This is going to give me 3 values to compare. And it's going to be really easy to see that Texas is doing much worse than Minnesota and Wisconsin. And I can quantify that by looking at how different those medians are. But when you do that approach, you are throwing away a lot of information. In fact, you're only looking at 3 particular values across your entire CDF plot when making those comparisons. One nice thing about comparing CDF plots is it allows me to compare the entire spectrum of the data to one another. I can make statements like, the best county in Texas is doing worse than all of the counties in Minnesota. Okay, I can do that because of what I see in the CDF plot. I can't do that based on just a comparison of the medians. And then finally, on the very bottom here is those compare densities, and those are using those smooth curves. Okay, that does it for part C of handout number 9. Thank you very much.